What happens to a star when it dies? In order to really understand the death of stars, you need to understand that there are actually three types of stars: low mass, medium mass, and high mass stars. The low mass stars, which make up the majority of our night sky, live for a long time and burn red, which is why it can be seen pretty clearly in the night sky. Yet when these stars eventually run out of fuel, they slowly fade away and become dim. Medium mass stars, like our sun, will eventually turn into a red giant. It will expand and grow into Earth's orbit. When a medium mass star runs out of hydrogen in the core uses helium as a fuel. Hydrogen continues to burn the outer shell, while the core will change size and expand, and the colors changes as well. However, once it burns through the carbon core, the outer fuel will turn into a cloud, which becomes a planetary nebula. And this nebula will be a glowing cloud. At the center, there will be a white dwarf, which is the remains of the red giant's core. It will be super hot and bright, but over time it will cool to become a black dwarf. It is the high mass stars which are the ones that ultimately become a black hole and other destructive forces. These stars have a mass 8 times that of our own sun. Nevertheless, these stars have short lives. The colors of the stars show their life cycle: white to blue to red, and finally an explosion called a nova. Blue stars run hot and burn fuel until fusion creates a new element. For example, hydrogen will become helium. Eventually, the core runs out of helium, but it continues to fuse together atoms which make new, heavier elements in the core, including carbon. Once ions reach for the fuel in the core, the star can no longer produce enough energy to withstand, and the star collapses and explodes. The nova explosion is extremely violent and can be seen hundreds of light years away, but it is the aftermath that captures the attention of the astrophysicists and astronomers. The explosive supernova is not exactly the end of the star. The core will either implode and create a black hole or a neutron star. A neutron star is a type of star that is one possible result of a supernova if the star's core is between 1.4 and 2.8 times the mass of our sun. Neutron stars are so dense they can take the mass of our sun and reduce it to the size of a city with a huge gravitational pull. With a neutron star, unlike other stars, the core is made of iron particles called neutrons. Because of the intense gravity, the core is some sort of liquid not found on Earth. The neutron soup inside the core will prevent the star from shrinking anymore. Normally, electrons repel each other, but due to intense pressure, protons, electrons, and subatomic particles smash together and merge to become neutrons. In 1967, Jocelyn Bell discovered a constant noise that was disrupting data from a radio telescope. This disruption was a pulsar. Pulsars are neutron stars with a rapid rotation in the magnetic field that sends out twin beams of energy away from the star. The beams sweep around as the star rotates. Pulses can be detected as the visible light radio waves and X-rays. Some spin 100 times per second, called the millisecond pulsars. If they spin faster, it would rip the star apart. Magnetars are very rare. They have short lifespans. They spin slowly, which helps strengthen the magnetic field. However, the magnetic field weakens as the star spins more slowly. In a neutron star, the crust and magnetic field are locked together, so a change in one affects the other. What does this mean? The crust of the star is incredible strain due to the intense gravity and rapid rotation. If the structure slips, it can snap, creating a starquake. Starquakes are tremendous explosions in the crust that release energy trillions times stronger than a solar flare. It can release as much energy as the sun gives off in 250,000 years. Not all neutron stars are pulsars, and not all neutron stars are magnetars. While neutron stars, pulsars, and magnetars can be a possible side effect of a supernova, the one that captures the imagination of everyone who knows even a little bit about astrophysics and astronomy is the infamous black hole. If at the end of a massive star's life cycle, the core is more than 2.8 times the mass of our sun, the gravity of the core can overcome the tremendous resistance of the neutrons and will shrink to the size of an atom and become a black hole. No light could escape its gravity, which sucks everything in. There are two kinds of black holes: stellar and supermassive. Stellar black holes form an extremely high mass stars experience a supernova. Supermassive black holes can be found at the center of most galaxies. Nothing can escape a black hole because nothing travels faster than the speed of light. If someone were able to get close to a black hole, they would experience spaghettification, which is when gravity pulls at one end 1 million times stronger than the other, stretching infinitely. Black holes are only a threat if you are near it. Black holes emit radiation and cosmic winds. The gravity of a black hole drags gas and dust into an accretion disk around it, and the disk spins faster and faster. As the accretion disk spins, magnetic fields are created. As the spin intensifies, the magnetic field coils up, which forms a vortex or tornado. It is referred to as jets. The jets limit gas and therefore limit the amount of star formed in the center of a galaxy. As you've learned, astronomers have unlocked many secrets of the stars in our universe. However, I am sure that there are many more to be discovered. Please go to my blog at blogs.scarsvilleschools.org for more information.